Hi girls, hello, good morning, welcome from the COVID chemistry bunker. I'm just going to do a quick mind map for you on the atmosphere. Hopefully that helps. I've just done a kind of a talk through of the atmosphere topic, and I've put the notes in your folder, so hopefully that's useful. And I suppose the final thing is just to try and make a little mind map here of so I can kind of try and show you how to link all this information together, because there's a lot of information on this topic, but it's not necessarily difficult. There's just a few equations and things that you need to be familiar with. So I'm going to try and do that now. Mine is going to look very sloppy because I'm naturally sloppy anyway, but also I'm doing it in a bit of a rush, but hopefully it'll at least just show you how things link to each other. Okay, so it's not really about the quality of my individual mind map. It's just about me talking through how the different gases and stuff link to each other. Okay, so hopefully that helps you in some way. Right, let's get going. So what are we talking about? Basically, in the atmosphere, we're talking about air. And the first thing that we need to do is split this air into its constituent gases. Isn't that right? And we do that by distillation. Okay, so what happens is that cold air is passed through a big pipe here. It's cooled to minus 200 degrees where the water and the carbon dioxide is filtered off. And then it's passed up this big distillation tower. And the higher up the tower, the hotter it is. So that means that gases with lower boiling points, such as oxygen, will be distilled off quicker because they'll condense at a temperature. They'll boil at a temperature which can be removed there. Then you've got argon somewhere in the middle. And then at the very top, you've got nitrogen, which is removed. Okay, once the nitrogen is removed, we go up here. That's used for lots of different things. It's used for keeping food fresh. Okay, again, I'm just scribbling some words to help you and to help you think of concepts and ideas around this. Okay, so it's used to keep food fresh. It's used to remove warts, very important. And it's used to fertilizer, which is kind of obviously the most important, isn't it? So it's used for fertilizers. Okay, so be aware of some of the uses of nitrogen and also be aware of nitrogen in the atmosphere. So we need to know about the nitrogen cycle. Okay, now I'm not going to do a mind map on the nitrogen cycle for you here. Hopefully you're familiar with that. But you should be familiar with nitrogen fixation and what that means. So nitrogen fixation is all about changing nitrogen gas into nitrates. Okay, so a useful way of taking inert nitrogen gas and making something useful. And there's basically two ways of doing that. One way is with lightning, and the other way is with certain bacteria. Okay, so be familiar with both of those processes, a way of turning inert nitrogen into, that should be a minus one charge, shouldn't it, into nitrates like that. Okay, so that's a really important process. It's important to know how that happens, all right, and what happens there. Right, let's look at carbon then. Okay, so when we look at carbon, there's a couple of things that we need to be familiar with about carbon. The first thing is that it can burn to produce carbon monoxide, which is really dangerous. Okay, you've all seen the ad on TV with the little bird in it. I mentioned that in the clip as well, didn't I? I need to shut up about that. Half O2 plus carbon monoxide. Okay, so that's how carbon monoxide is produced. And then we've got carbon dioxide. All right, so that's carbon dioxide is here. Okay, so that's carbon plus O2 gives us CO2, like that. Right? Really important that you know how carbon dioxide reacts with water. Okay, so this is a natural process. We mentioned that in our slides. Okay, so carbonic acid is a weak acid, so we need to have arrows going in both directions like this. Okay, it's a weak acid that's produced when carbon dioxide reacts with water, and it dissociates, not surprisingly, like this. Okay, you've got H plus HCO3 minus. Again, I'm a bit sloppy here, but I've done this in the video a bit better, haven't I? Sorry, that's really sloppy. H plus H, can you see that? CO3 minus. Okay, so in other words, you need to be familiar with how carbonic acid is formed and how it dissociates. So make sure you can write equations for that there. All right. Another really important concept here is obviously climate change, isn't it? Greenhouse gases. Okay, so be familiar with what a greenhouse gas is. That's a really important idea. Make sure you know some other examples of greenhouse gases. Methane is a good example. CFCs are a good example. You might want to write them in there as well. Okay, again, I'm being a bit squashy here, but I'm just writing words as I think of them. Okay, I'm doing my own scattered kind of mind map. You can do a much neater one when you've read through the notes and you've listened to this nonsense and you've finished with it. Right, so carbon then. One of the other things that we need to be aware of is acid rain, okay, and how acid rain is produced. So acid rain can be produced either through carbon, through nitrogen, or through sulfur. All right. So sulfur is another gas that can lead to acid rain. All right. Sulfur reacts with, I'm down here now, sorry, can you see that? Reacts with water to produce sulfurous acid, H2SO3. And that SO2 also reacts with water to produce sulfuric acid, H2SO4. All right, so be familiar with those processes. How do we remove that? We remove it by scrubbing. Okay, again, we mentioned that in our slides. Scrubbing is produced when calcium carbonate decomposes to calcium oxide, CaO plus CO2. And then that calcium oxide reacts with sulfur dioxide to produce calcium sulfite, okay, which can be removed from the inside of the chimney. I mentioned that in the clips as well, all right? That's really, really important. You should know how acid rain is produced from nitrogen as well. So acid rain can be produced by carbon dioxide gases, sulfur dioxide gases, or nitrogen dioxide gases. There's lots of different forms of acid rain. So make sure you know how nitrogen dioxide reacts with water to give sulfurous acid and sulfuric acid. Okay, H2SO4. So just be familiar with that. Again, this kind of goes in our nitrogen section. We've got our carbon section and we've got our sulfur section. And these are all linked to each other through acid rain and through a lot of the problems that happen in our atmosphere. Right, there's one last section that you need to be familiar with in this topic, and that is ozone. So make sure you know what ozone is. Okay, it protects us from UV damage. All right, make sure you know what its purpose is. Make sure you know how it's formed. So we're going to write formation here. And we're going to write O2, that's oxygen, plus sunlight, gives us O3. Okay, that's ozone gas there, right? So what happens is that sunlight splits up, doesn't it? I should really write that in 2 steps. So I'm going to write that like this. So the oxygen splits up homolytically into 2 radicals like that, and then those 2 radicals react with oxygen to form O3. Is that okay? So I've done it in 2 steps there. Oxygen reacts with sunlight. The oxygen is split homolytically into 2 radicals. One of those radicals reacts with oxygen to give O3. So now we've got ozone. That's ozone there. Okay. So what does the ozone do? Well, the ozone works by reacting with sunlight to give oxygen and the ozone radical. Literally the opposite of what we've just written there, okay? That's how it works. It protects us from the sunlight by sort of sacrificing itself into oxygen gas and an oxygen radical like that, okay? So make sure you know what CFCs are. CFCs are chemicals that look like this. They're like methane, but they're substituted, okay? So chlorofluorocarbons, where we've substituted the hydrogen for halogens, okay? So that's a CFC. It's very dangerous. We don't use them anymore. But what happens is that they break down, okay? So CFCs break down like this. So CCl2, F2. Can you see that? Yes, you can. And they form chlorine radicals, okay? In much the same way as we talked about when we talked about reacting alkanes with chlorine radicals, okay? So ClF2 radicals like this. All right, they produce radicals like that. And then what happens is ozone is depleted. So there's depletion reaction like this. Okay, so it's depleted. We've got oxygen, reacts with those chlorine radicals to give us chlorine oxygen radicals and oxygen radicals here, and oxygen molecules like that. And then what happens is those radicals react together to produce oxygen and chlorine oxygen radicals like that. Okay, so this sequence goes in cycle like that, and it leads to the depletion of ozone in the atmosphere. Even one of these molecules can cause hundreds of thousands of molecules of damage, break 100,000 molecules of ozone down into oxygen like that. Okay, make sure you're familiar with these equations. They're in your slides as well. Make sure you can write them and you know what they are. And that's it. I mean, it looks like an absolute mess when I've done it like that. But the point is, you can see how they're all linked. Okay, so you need to know how gases are isolated. You need to know about nitrogen fixation, cycling, how it's used. You need to know about carbon reaction with oxygen, and carbon dioxide's reaction with water to produce carbonic acid. You need to know a little bit about sulfur dioxide reacting with water, how that sulfur dioxide is removed from the atmosphere by scrubbing, and then you need to know how ozone is formed, how it works, how CFCs disrupt it, and how the ozone is depleted. And a really important point that I forgot to mention in my slides there is that an alternative to CFCs are called HCFCs, which literally occurs when you replace these fluorines with hydrogen, okay? So I'll replace them like that, and that's called HCFCs, and they're used nowadays, and they're much safer. Is that okay? So I hope that helps, guys. Puts it all in one page for you anyway. Good idea is for you to go back now, look at the notes, try and make your own mind map, and then have a go a couple of the questions and let me know how you get on. All right, thank you.